Hi everybody, and welcome to the Learn Solidity in 15 Minutes course for the Harmony One blockchain. Today we will learn how to develop in Solidity, how to quickly deploy a smart contract onto the Harmony One testnet, how to get some One tokens, and how to configure Metamask to point to the development and production instance of the Harmony One blockchain. This is a one-on-one course on developing in Solidity and using the Remix IDE. Hop over to the GitHub repo for a deep dive into the Solidity language and its different constructs. Now, before we dive in, let's talk a bit about Solidity. Solidity lets you program on the Harmony One blockchain, a blockchain-based virtual machine that allows the creation and execution of smart contracts without requiring a centralized or trusted party. This means that anywhere in the world you can deploy a smart contract onto the Harmony One blockchain, have it run, and no one on earth can stop this. That's what it means by being completely decentralized. So let's get started. We'll be using the web-based IDE called Remix to develop and deploy code onto the blockchain, and the Metamask wallet to manage accounts and sign transactions. Both can be found in the video description. Before you begin, make sure you install the Metamask wallet plugin. Just download it onto your Chrome browser, Chrome or Brave browser, and then enable it, configure the necessary steps, and then you're ready to go. So to begin, let's launch the Remix IDE and explore some of its functionality. We're going to use a preloaded example called Simple Bank. And a Simple Bank really is just a bunch of functions that allow you to transact on the blockchain. And it simulates a simple bank example, being able to deposit, withdraw, and view your balance. So if you go to the repo, you'll see that there is a link. If we just click that link, it'll actually launch up the Remix IDE with the Simple Bank loaded. So we go to the File Explorer. This is the Remix. Click the Solidity plugin. Let's go back to the file. We can load this file called Simple Bank, and you can just explore the Simple Bank example, a solidity-file.sol. In this case, we're looking at Solidity version 0.6.6. So some of the versions will enable some of the programming features. I think 0.6.6 is quite recent. Yeah, so just have a look at the smart contracts. I'll walk through this smart contract at the latest part of the tutorial, but what we'll do now is we will just quickly deploy this. So what you do is you go over to this button here, which just allows you to compile. So the Solidity compiler, you select the compiler, the language, the EVM version. We'll just pick it up from the SOL. Just click compile, and you'll see everything works. So you have the option then to publish on IPFS, Swarm. We won't go into details. This is just to publish the source code on there so other people can see it and access it. And then view what was used to generate the smart contract code. So once that's compiled, you can actually deploy that into the blockchain. So as you can see, in this example that we're doing, we will actually be just deploying this onto a JavaScript virtual machine. So we're simulating this inside the browser, the actual blockchain transactions inside the browser. This makes it much easier to not only deploy, but also to debug. But the problem here is, once you've deployed it onto a virtual machine browser, no one else can access it. So first I'll show you how to deploy it onto this JavaScript VM. And then the next step is we will actually go and get some One tokens and deploy it onto the actual mainnet, onto the actual testnet itself. So let's just click the deploy button and take a bit of time. The contract then is deployed. So now you can see from the logs it's been deployed, where it's deployed, a bit of information about how much gas was used, etc. So in general, when it's inside the virtual machine, it will just simulate some of this transactions, this information. But once you deploy in a proper testnet, you actually see the amount of gas used, the hash, etc. And you can actually go and inspect that on the blockchain itself. So what we can do once we've deployed is actually start interacting with it. So you can see we have a deposit, a withdrawal, a balance, and an owner. So we can see the owner is this particular address. So whoever actually executes or creates this smart contract and deploys it onto blockchain will be the owner of that smart contract. Not only that, you also see where the smart contract resides on the blockchain, and this is a particular address here. You can have a look at the current balance of the user. So in this particular case, my user, who is also the owner, has a balance of 0. But what you can also do is you can just switch out the users, because this is just a virtual machine. We've actually preceded a whole bunch of accounts. So let's have a bit of a play. And I encourage you to explore this, and not only that, but also to make changes into the smart contract and redeploy it and see what happens. So it's a very good idea to try, when you're learning, to try out a few things to be able to test it out. So let's just try some things. We've got our balance. Let's try the deposit. The key thing here for deposit is the smart contract actually uses one tokens themselves. So when you deposit, you actually have to specify how much money you want to transfer into this particular smart contract. So if you look at the GitHub repo, we actually explain what some of these fields mean. For this particular one, deposit, it's a public function. This payable is a very special modifier that tells the blockchain that this particular function can accept 1 tokens. If you don't have that payable there, if I transfer way into that function, and when I call it, it will actually fail. So let's give the deposit a try. So if I go ahead and deposit 1 way into my bank account, so right now, before I do that, I see a balance of 0. If I deposit that, and then I check my balance again, I'll see that the balance has changed to 1. If I change my account and then I look at balance, I'll see that the balance is now 0 again. What I can also do is withdraw that amount. So I can withdraw that back into my account. And then again, I see the balance is now 0. So basically what we've done is we've taken a smart contract, very simple one called bank, simplebank.sol, deployed it onto the JavaScript virtual machine inside your browser that represents a blockchain running behind the scenes, and then we've interacted with the blockchain. To do that, let's configure Metamask to actually talk to the Harmony One blockchain. Alright, let's configure the Metamask plugin to point to the Harmony One testnet. First, you click on the Metamask plugin, click on the Ethereum mainnet, and as you can see, it has been already pre-configured to point to the Ethereum mainnet and a bunch of Ethereum testnets. So we click on custom RPC and enter the details here. And one annoying feature that I've found about Metamask is that, let's say you're halfway through entering the details and you tab out, you actually lose all your configuration. So the easiest way to work around that is to actually just copy the configuration that you have and paste it into a document. And it just makes your life a little bit easier, so you don't have to tab out. Harmony One testnet, RPC, chain ID, currency is 1, block explorer, okay, let's click save, and now it's selected. So if we just close this, now we can see our Harmony One accounts. So I've got a test account already with about 2001 tokens. So there you have it. That's how you configure the Metamask plugin to be able to point to the Harmony One testnet. You can do the same thing for the mainnet as well. It's quite straightforward. Just follow the tutorial that's been provided by Harmony One in the documentation that's been linked in the GitHub repo. So once we've got our Metamask configured to point to our Harmony One testnet, we can now try and get some 1 tokens from the faucet. So we just hop on over to the faucet. Let's go back to the repo. You can see there's a link to the faucet. Click on that, and then you paste your Ethereum address in there. Now the trick here is, this address here is Ethereum. So if I paste that into faucet, it's gonna fail because it's not a recognized BEC32 address. So to get a valid BEC32 address, the easiest way to do that is to actually go to the block explorer itself and copy your address and then paste it into the search bar. So Harmony1 block explorer will actually translate any Ethereum address into its relevant one address. Just click the copy button and then go ahead and paste that into the faucet. So it'll take a bit of time, and once it's validated, you will receive 1001 tokens. So if we look at our balance now, it went from 2,000 to 3,000. So now what we've done is we've configured the Metamask wallet to point to Harmony1. We've gone to the faucet to be able to get some test tokens. Now we're going to go back to the Remix IDE and try to deploy this contract onto the Harmony1 testnet. So the first thing you do is you go back to your deploy and run. What we can do is we select the environment. So instead of using our JavaScript virtual machines, we go into the injected Web3. So the injected Web3 is the actual Metamask Web3 provider. If you haven't already granted Remix access to your Metamask account, a notification will pop up asking you to confirm. So you choose the account that you want to connect to Remix. Click Next, review the permissions that's been asked, and then click Connect. Really, this is just an extra step, a manual step, so that malicious websites can't come along and start transacting on your blockchain, transacting using your wallet. So once you've got your injected Web3, we can go ahead, compile it again, and then make sure everything's good. We can then just click the deploy button. When we click deploy, a pop-up or Metamask will pop up asking you to confirm this transaction, and we have to pay a little bit of gas. So gas fee is 0.0031 tokens, and we're looking at 10 gig away for our gas price, and setting a bit of a gas limit. So just click confirm, and we'll just wait for it to deploy onto the blockchain itself. This may take a bit of time. Once it's deployed, we can see the information about where it was deployed. So now what's happened is, instead of deploying onto the Java virtual machine running on your local browser, we've actually deployed it onto a public testnet. What that means is, if I was to say expand this and we copy this address, we can go ahead to the Harmony blockchain explorer and actually see the contract. So you see, if you paste that in, it will convert to a one address. If you look at the contract, we can actually see the IPFS hash and the bytecode. So this is a valid contract that has been deployed on the Harmony1 blockchain. If I start interacting with this and transferring tokens, calling deposits, checking the balance, and doing withdrawals, we can see all of these events happening on the blockchain explorer. So let's go ahead and try to interact with this smart contract. So let's have a look at the balance first, and we'll see that the balance is 0 for this particular user. You can see the owner of the smart contracts. You see the balance is 0. If I try to withdraw anything, it will fail because we don't have any balance in there. So let's go ahead and try and deposit one token into there, or two 1 tokens into there. What I found the easiest way to do that is to go to fconverter.com and just enter the amount of 1 that you want to do. So 1 and Ether are interchangeable. the contract itself takes away, so we'll just copy and paste this very large number. And let's go ahead and deposit it. So you need to edit this particular section because this section is used by the transaction when MetaMask sends that transaction to the blockchain. So we set up the gas limit. We also set up the value that we want to transfer. So be wary, you have to set this value when you're doing a transfer. So let's go ahead and deposit that to 1 tokens. And you can see MetaMask will pop up saying, hey, this particular smart contract, this particular action that you just did will result in you transferring 2-1 or depositing 2-1 into this smart contract with address blah. And it will cost you some gas fees as well. So total estimated cost is about 2.1. So we just go ahead and click confirm, and we'll just wait for that to happen. So before it happened, you see it was 3,000. Now that we've done the transaction, your total balance has dropped to 2,998, or whatever balance you had before. What we can also do then is we can inspect that transaction. So if we go ahead and open the results, so this is the transaction receipt that gets sent back from the blockchain. If we go ahead and open that, expand that, and copy the transaction hash, we take that transaction hash and search for it inside the Harmony Blockchain Explorer. We'll see exactly what happened. So you can see the status was successful. This is the transaction hash, block number, timestamp, who was the sender and the receiver, and the amount that was sent, which in this case is 2-1. If you click on the receiver, this is actually our smart contract from earlier, and you can see a few transactions that have happened. So previous smart contract, and you can also see that for that particular hash that we had, it was a transaction that was sent from this address to this address, and the value that we sent was 2-1. So now I've actually deposited 2-1 into my smart contract. Now, the interesting thing here is that a smart contract and an address are first-class citizens on the blockchain. What that means is everything that an address can do, a smart contract can do. So an address can send and receive 1 tokens. Likewise, a contract can do the same. The great thing about a contract is that you can actually start programming logic around how that token gets received, how that token gets sent. So you can effectively program money, which is a very interesting concept. So now you see we've actually deposited 2-1 tokens into the smart contract. If we go back and look at the balance, we'll see that we now have 2-1. And so just to verify that, you go back to the Ethereum converter, paste that in, and then you can see it's converted, it's 2-1. Now, what happens if we try to withdraw 21? If I click withdraw, it'll pop up with an gas estimation error. And the reason it happened, and this happens, is because when you call that function, a revert happens on that function. And if you go ahead and look at the withdraw function itself, you'll see the reason. So the withdraw function takes the amount that you want to withdraw and returns the remaining amount that you have left. This is the line that causes that revert. What it's saying to the blockchain is that when this function is called, before you do anything else, make sure that the total balance of the caller is greater than or equal to the amount that the caller wants to withdraw. So that's a check. If this check fails, what happens is the blockchain will throw an exception, and then the caller will get a notification saying, hey, the transaction has failed. In this version, it doesn't actually tell you why it failed, but in a later version of Solidity, you can actually put an error message in there as well. Maybe you can say something like the balance, the user's balance is too low, or something like that. If I go back. So now what do we do? Let's go ahead and try and withdraw 1,000, 1F. And as you can see, we set this value to 0 because we don't want to actually send Ethereum there. So if I was to send some Ether on that call, it will also fail because the withdraw function is not payable. So because the withdraw function is not payable, if you try to send 1 tokens to that address, when you try to send 1 token to that function, it will revert and fail. So let's just set that back to 0, and then we'll try and withdraw 1 token. So when I click on that, once again, Metamask will pop up saying, hey, the action that you did will cost you some gas. Please confirm that transaction. Go ahead and click that, and then we just wait for that transaction to complete. And once it's completed, we can again expand it and inspect the results, inspect the actual hash itself. Copy that, go to the Explorer, jump in, and we can see now we didn't transfer any ones, and a few things have happened. If I go to my balance, I'll see that it's increased by a little bit. So it's increased by 1. Before it was 2998, now it's 2999. So as you can see, the balance is now decreased by 1 on the contract itself, and your balance has increased by 1. So if we go ahead and look at the balance again, we see now it's decreased to 1 token. We go ahead and withdraw that again, and we just wait for that transaction to complete. You see now my balance is 0, and I've reclaimed my 3,001 tokens less the gas fees. So there we have it. What we've done is we have used Remix to deploy a very simple contract onto the Java virtual machine for internal testing, as well as the public blockchain. So that's all we have for today. Thank you for your time.